Hi guys, this is a calculus video. This is recovery video 4. And recovery video 4 corresponds to this method of anti-differentiation or integration. And this is when you say yes to this question. Can I use the f prime over f formula? And here it is. This is something to memorize. And we will be using that formula when we have these clues. The input of the integral is a polynomial over a polynomial, clue number 1, but then clue number 2 has to apply as well. The numerator is a constant multiple of the derivative of the denominator. Okay, now, so you want to, all right, so we have a polynomial over a polynomial. A constant is in fact a polynomial, guys. It's a polynomial of 0 degree because we can represent this as 1x to the 0. And then the denominator is also a polynomial. So I'm gonna do this. All right, so if I let f of x equal 2x minus 5, and then I take its derivative, so f prime of x equals 2, this numerator, I can very easily make this numerator 2 because it's 1 now, but 1 is a constant multiple of 2. Yeah. So I'm only off by a constant is what I'm trying to say. So if all you are is off by a constant, you could force this constant to be there. So I can just multiply that by 2. But I can't just multiply by 2. If I multiply by 2 on the inside, I've got to divide by it on the outside. So I'd have to go 1/2 on the outside. Okay, and now I've got f prime of x over f of x. And whenever you have this, okay, so this is a definite integral. I want to do a definite integral because it's a little bit harder. But this is going to be, okay, so I'm just going to carry the 1/2 over. All right, so this is equal to, all right, I'll just carry the 1/2 out in front. Opening up a bracket for -2. The antiderivative is what goes inside here. Okay, remember the output of a definite integral is going to be the area under the curve of the input. But in order to get there without a calculator, we have to find the antiderivative and put it in that bracket and then plug in the upper and lower limits and subtract. So the antiderivative of this, I've got that formula for it, the f prime over f formula, and it is the natural log of the absolute value of the denominator. No need for a plus c here, guys, because the fundamental theorem of calculus says I can put any antiderivative in here, and I'll just use the one where the plus c would be plus 0. Okay, guys, so now this 1/2 comes down. Okay, I'm going to plug 4 in there. So the natural log of the absolute value, so 4 goes in there, so I get 8 minus 5. So 3 minus natural log of the absolute value of, so now -2 is going in there, so I get -4 minus 5. So I get -9. Okay? And that is an actual number. All right, so let's just leave it like that. Yes, let's just leave it like that. Okay, you could simplify it, but it's really, the AP people don't really require you to simplify. But if you plug that in your calculator, you'll get a number. It'll be an irrational number, but a number. And then if you want to test this answer and see if it's right, if I haven't made a mistake, plug the original into your calculator under Math 9, and we should get the same irrational number. Okay, guys, so that was recovery video 4. Bye-bye.